No, not at all. It's my pleasure, Anil. It's great to be with you.
Yeah, right before this, we had an opportunity to hear from Bob Metcalf about build-outs throughout the 80s and 90s. So you've got a tall order. I know you admire Bob as much as I do. So maybe one place to start is, there's so much build-out happening now. What do you think will make or break the next decade of this infrastructure build-out that's happening now?
Yeah, I mean, the way I think, Anil, is each of these build-outs of infrastructure always comes down to two sets of things, right? How efficient is the build-out for what is the new platform? And then what's the way it gets to ubiquity? In some sense, it's the app server, right? I've always thought about, at least from a platform perspective, what's the core primitives of the platform? And then how does the platform have a developer interface so that developers can use it, right? I mean, at the end of the day, you could say that's what operating systems are, right? So the operating system book, at least I read in school, was that Tenenbaum thing, which is you abstract the hardware and expose an app model. And that's a good way to, I think about the infrastructure. So in that context, the first thing is, how do you make things efficient? This time around, it's that tokens per dollar per watt, right? So the token factory has to be super efficient. So there's a lot of work that goes on, I think is going on, is at the systems level, all the way to power, right? And so that's one side of it. Then on the app server side, it's more like an agent factory. So if you have a token factory, so think of it just as throughput's got to be most efficient. But then you got to harness that to build very efficient, effective agents. And that is an entire different ball of wax, right? Which is you got to have a set of application services so that any agent that you're building delivers on some eval metric that matters in the world. And so those are the two, at least I think, as the infrastructure pieces.
Yeah, I think you have such an engineer point of view of this, and I remember you mentioning this sort of complete thought from silicon to operating systems to applications. How do you think that cascades down to the core part of how networks are designed in all this build out and across the WAN and the edge, and how do you think about that?
Yeah, I mean, it's fascinating. I mean, obviously what you all are doing, in fact, the first time I remember you and I chatted, when you said you're going to vertically integrate, build this network as a service platform. It's pretty impressive to sort of say that's, I think, a little bit of what we are also doing, right? When people say, wow, there's a lot of CapEx being spent, I mean, the reality is the data center as the computer is becoming more real today, right? I mean, that's kind of where you want to really think about the complete thought is how do you really go deliver on that tokens per dollar per watt. But just take one of the new data centers we just brought live last week or a week before called Fairwater. I mean, interestingly enough, we built it as a double-decker data center. This is the first time we did that. And we did that because in fact, for the network, which is, can you have the 5 million network connections that are there in that particular data center optimized for cable length, right? Because we wanted the most dense GPU environment. And so in order to do that, you kind of had to even rethink the construction, if you will. And so to me, and then not only did we do that in one data center, but we also built an AI WAN. I was sort of very pleased to see you all working with Lumen and building your own sort of connection between what you're doing and what they're doing. In fact, that's kind of a similar thing we did. We now have, we have a Wisconsin Fairwater and Atlanta Fairwater, and both of them are sort of networked through this AI WAN. So you can now run distributed training across these. So to me, that's, I think, what you kind of take the workload. I worked for this gentleman who at Microsoft called Paul Maritz a long time ago. He used to always teach us as systems folks growing up, saying, look, at the end of the day, you really want to fall in love with sort of what the new workload is and then design infrastructure and application servers. So that's what we're doing. You look at these new data parallel workloads, which kind of are unlike anything we've seen before, are training, inference, data gen, data pipelines for all these eval rubrics, what have you. You go build for that, and that's where I think the infrastructure is being rethought end to end.
Yeah, Dwarkesh is here somewhere in the audience, but I watched the interview you did with him and the scale of the build out. how do you feel as an engineer? Like, these are mass scale projects. How do you think about this? And, you know, as an engineer, I know, like, you understand these systems. Are you in awe just as much as the rest of us are to look at the scale of this?
Yeah, I mean, I must say we're in awe of it, but I'm also, quite frankly, humbled by one factor, Anil, which is the amount of expertise that is required to pull something like this off, right? If you think about the electrical engineers, the mechanical engineers, the construction, civil engineers, obviously the computer engineers, all of them coming together, composing on a project timeline, making something like this happen, delivering on an SLA. So to some degree, it is what I'm in awe of. And I also feel that this is one of those places where we've got to get it right, that not only do we have to build stuff that works and works super efficiently, but it's also to do what? I think that's the main thing as engineers, because for the first time, when I say tokens per dollar per watt, if you're really going to consume a lot of energy, one thing that I think we all in this era have to be more grounded on is the social permission to go take that type of energy, convert it into tokens. It's not going to be about celebrating like some eval that you and I can get hyped about. It has to be something that the world actually benefits from.
You guys are building out the entire stack, like you mentioned, which is amazing to watch. How do you think you maintain that while also thinking about reliability and trust, because so many companies depend on what you guys are doing and how much you're building out?
I mean, that's sort of, when I think about priorities for us, quite frankly, there are three at the company. One is security, because the cyber landscape just becomes even more complex every day. And then quality and reliability. And if you do a good job on those two, you get sort of permission to even think about AI. That's kind of, I'm pretty clear that that's the sequence, the order of operations even for us, because if I look at Azure today in the 60 plus regions around the world, people count on it as critical infrastructure. And so therefore we don't take it for granted, and so you have to think about operating it with those qualities and the fundamentals. And that I think is the key, right? Which is these are at scale, nothing is a commodity. It's sort of very complex, and so therefore and in fact, if you think about it, the primitives have to be rethought, right, for the next 10x. Everything, right? And so what you build for, like we've added more data center capacity in the last 18 months than perhaps in the first 10 years of Azure, right? So if you sort of say that's the scale, then some of the core primitives have to be rebuilt. But then on top of it, there's one other thing that you brought up, which I think is super important, which is operating around the world requires us to respect what I think of as the legitimate sovereignty needs people have, right? Because in Europe, they have their own data protection laws. So therefore, for example, one of the hardest projects we did over the last 5 years is the EU data boundary. Right, which is how do you make sure that all the data that is European remains in Europe, right? So that's the data plane. Now we have a control plane that goes with it, that is resident. And so we've kind of continuously built for what I think is a distributed infrastructure, but with real sovereignty boundaries. And now with AI, we're even getting to another new sovereignty boundary, which is at the end of the day, every firm wants to know that their data and their unique understanding of data is being parlayed into their competitive differentiation versus just fodder for a model company. And so that I think is one of the more interesting sovereignty debates, right? What's the future of a firm, right? If the firm is all about knowledge you have, which is tacit inside, but if a model, can see 200 great samples of data and pick it up, then that's a problem. So therefore, you really need to think about even sovereignty at the firm level very differently.
I remember you saying like the hardest part is not the models, but changing how people think and work with the stuff. What have you guys seen work best? What are you seeing from your customers, and how does that work? Because everybody has a different perception of how well these things work, how they don't, or where they're accretive or not. What have you seen in that change of in how people think and work with these models?
Yeah, I mean, I think the first thing that is interesting that I see when someone, besides sort of, let's say, the hit app, right, whether it is ChatGPT or Copilot that you can deploy, use, and if you go get beyond any first-party stuff that we're doing, right, even GitHub, Copilot, or what have you, for an enterprise, they need to start with, I think, a little bit of a change in mindset, which is we built all the workflows at work based on a particular regime of digital infrastructure. I mean, the reality is nothing much has changed since the beginning. When I started in computing, in terms of the workflow, right? I mean, we had PCs, and then talking to minis, and then PCs started talking to servers, and it became client servers, right? That's sort of what was the last time people said, oh, we'll have standard issues of office productivity, we will have email, and it'll replace fax machines and inter-office memos, and we will now be able to do a forecast in Excel, put in an email, send it around, people can enter numbers, and so there it went. And we'll buy an ERP system, a CRM system, we'll have a system of record. So we kind of built a pretty sophisticated, I'll call it, digital information backplane. And now it's time to relitigate the entirety of it, right? Because you kind of say, okay, this is how work happens today, but I need a mindset shift on if I have multiple agents working alongside all of the human workflow with digital systems, how do I change the process of something like even forecasting? And I think that's the first one. The second thing is you need a new tool chain, right? So you kind of need, just like how the tools of the past were, or I had Word or I had Excel, what are the new tools to be able to build agents and deploy agents, monitor agents, steer agents. In fact, so there's a complete new tool chain that is required. Then that requires us to develop skills, not like the elite sort of AI scientist skill. Like it's sort of, we may have taken a class or two of Excel macros, but we all could sort of use Excel. So I think everybody's going to be building agents like they build a spreadsheet. And so that's the skill set that needs to be broadly diffused. And then the last thing is data. Because if you think about it, the most interesting thing that we do is to do this context engineering, which is how do I make sure that the data meets the intelligence that meets the process change I want to effect, right? It's not like data defined in the silos I have, because that's sort of like you have a very powerful intelligence and a reasoning engine, but it's only as good as the data you feed it in terms of what it should reason and how its action space. And so I think these 4 or 5 things have to fall in place, and that's the hard change management that we have, right? And it's sort of, we have to compress what happened. Think about it, right? All through the 90s and the 2000s, you could say. Right. Even in the cloud, like what did we do? Mostly we moved the same systems to the cloud. Right. So quite frankly, we've had a 30-year run, which was pretty stable in terms of how we thought about work getting done. And now we suddenly have to take that 30 years and maybe compress it, in the next 3, 4 years, 5 years, into something that yields massive productivity gains.
You all started working on Azure 10, 15 years ago, and a lot of the fundamentals that were set that led to being able to build these large models. If you knew that this is how much build out was going to happen, is there some things you would change on how you would do it differently? Like if you knew, in 2025, this is the mass scale build out that's going to happen to the level of national projects that hadn't been done before. Are there things you would do differently with that benefit of hindsight?
Yeah, I mean, so the interesting thing is we did have, basically the cloud build out was about making servers, right? Because much more, it was much more elastic than any of us thought, right? I mean, virtual machines, there was insatiable demand for it, right? People wanted to just spin up a lot more compute. One of the other things that I had not realized, quite frankly, is the amount of, I'll call it, capital that was spent on, say, storage systems underneath virtual machines, which suddenly now you could deploy a lot more efficiently. And so that, I think, created, and then of course the new workloads like the Hadoops and the data parallel workloads of that day, more batch processing stuff that was done at scale. this time around, I think it's kind of a new infrastructure, right? Which is, I feel we've not seen anything asynchronous, data parallel, stuff like this. And so therefore, that's why I think even the shape of what we're building, we've adjusted what we were doing to build for AI. But now when I look at even the way I think Azure will look 5 years from now, it'll look unlike anything we did in the first 20 years of Azure. And so you kind of reorient your core compute and storage and the network.
Right.
Or even, by the way, the memory interface. I think one of the more interesting things that may even happen is what's going to be the model architecture, the microarchitecture in the AI accelerator, and the memory. That's the thing that perhaps is going to completely change. And so, yeah, so I think my short answer is we have to rethink the core footprint of what one considers a cloud. Knowing at one end I have to run an SAP workload at 5 nines, and on the other end I have to run a highly efficient data parallel training job, right, which has the maximum token throughput. And so balancing that out in the right way, I think, is going to be one of the fundamental challenges for us.
In the last few build-outs, one of the interesting things that happened is after this build-out starts, maybe in the 80s, then in the 90s, things start to standardize. Today, if you go look at data centers and other places, every company is doing interesting things that they hold true themselves, but others might be doing different things than them. When do you think it'll be more standard on how to build this type of infrastructure where we have to standardize? And then maybe follow-up to that is, what do you think should be standardized? Or is it the way we're doing it now, where everybody does their own proprietary thing, is the way to go?
Yeah, I think it's a good point, because I think the specialization will come as the supply chain and the value chain here sort of really achieve scale, right? I mean, if I look at it, it's sort of, I mean, if you take the classic argument, right, which is if you have scale, you vertically integrate, it can be very tough, very efficient, very tied to sort of the idiosyncrasies of sort of how you think about whether it's your model or your application scaffolding and its requirements. But for us as a platform provider, I mean, like at this point, we have to make sure that any new thing that gets written runs on Azure. And so therefore, even at the silicon accelerator level, we have to be heterogeneous, right? I mean, at the end of the day, the workloads are going to be heterogeneous. The system architecture underneath those has to support, right, whether it's NVIDIA, AMD, and our own accelerators or what have you. And so I think that's how we're going to have to standardize, which is to basically build out what is a way to meet the real world needs, which by definition is going to be heterogeneous. And therefore, what's the set of standards that emerge? I think the first place is networking. If I look at the scale up and scale out network for these new workloads, all coming together, maybe the place, right? Because I think that, the model has still, and the model evolution has still a lot more influence on, I'll call it the microarchitecture of the one chiplet in the AI, accelerator, for sure. And its connection to memory. So some of that stuff may still be more fast moving, but everything else, quite frankly, you can standardize. And so that, I think, is where some of the exciting work, by the way, it has to go all the way to the edge as well. And I think that this is obviously a massive thing for you all to participate in, and we're excited about sort of being able to sort of say at the end of the day, what's this managed service around networking that spans the entirety of the distributed computing fabric, and that requires what you are doing as well.
And there's so many people here in the audience that are CIOs, CTOs, that are figuring out how to think about all these new tools that are coming out. Where have you seen the biggest ROI in Microsoft? Because you guys are obviously at the forefront, you have access to everything. How have those workflows changed the most?
Yeah, I mean, one of the fascinating things is the best news now for me, Anil, is when I start, hearing of the ground up use of the tools, right? Whether it's Copilot, whether it's Foundry, whether it's GitHub Copilot, people using them, right? So this is not some top-down mandate of, hey, because like the obvious use cases, I think we're all well on our way, right, to customer service or what have you. But the thing, for example, on networking, I had myself lost track of the number of, for example, fiber operators that power Azure. Like there are 500 plus operators that we have contracts with all over the world on our fiber operations. And I mean, at the end of the day, it's a physical asset. Things happen. There are fiber cuts. There's issues. And it's fascinating, the DevOps pipeline that is there. I mean, sometimes DevOps seems sophisticated. It's not like GitHub Actions. I mean, the thing is literally emails going on. And so one of our engineers, what she did was she took Foundry, built herself a bunch of agents. She's given them all names. Because she had to. There was no headcount. There was no way, even if she had headcount, she could grow a team to manage what was becoming the most manual of processes. And so she fundamentally agentified the entire process of dealing with triages around fiber operations and maintenance and cuts and what have you. And to me, that was like a great first-hand example. Same thing, to your point about supply chain and the data, these massive build-outs of our data center. You should see, I thought, man, maybe somebody, in finance or in legal will figure out how to do contracts. The people who needed to really figure out the agentic way to go get contracts done, because I did one data center contract here with this one supplier and replicated everywhere and so on. That's a place where completely the supply chain operations was completely inverted. I mean, if you think about supply chain, the basic way I've learned is, at the end of the quarter, you go to your CFO, you get beaten by the CFO for all the mistakes you made. And the idea now is to actually have these agents help with the daily beating, so to speak. And so that is the fundamental way you can completely transform a business process.
Amazing. Thank you so much for your time, Satya. I really appreciate you doing this.
My pleasure, Anil. Thank you so much.